Hi, now we're going to look at one of the past paper questions, and this is June 2005 from the C1 papers, question 6. So, as you can see, the part A is a linear inequality. There's no x squareds. So, we're going to start by multiplying out the brackets. So, 3 times 2 is 6, and there's also an x, so that's going to be 6x. Now we're going to do 3 times 1, and 3 times 1 is 3. On the other side, we have 5 minus 2x, so that's going to stay the same. Now, with linear inequalities, what you want to do is you want to have all of the x's on one side and all of the numbers on a different side. So, we need to add together all of our like terms. So, in our example, the like terms are going to be 3 and 5 and 6x and minus 2x. So all of the red or the x's should be together on one side and all of the numbers should be together on another side. So let's do a little bit of rearranging. I'm going to put the 3 over to this side, but when I put it over, it needs to change from plus 3 to minus 3. I'm going to do the same with the minus 2x. I'm going to move it over the inequality, and I'm going to change that to plus. So you can see everything is matching up now. 6x plus 2x, well, that's going to be 6 plus 2 is 8, so that's 8x. And over here, 5 minus 3 is 2. For the next step, what I'm going to do is divide both sides by what's in front of the x or the 8. So I'm going to have x is bigger than 2 over 8. Now, I can also simplify down 2 over 8 because this fraction can cancel down to be 1 over 4. Both of these can be divided by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So I have x bigger than 1 over 4. Like always, I'm going to draw a little diagram to illustrate where this region would be. I'm going to draw my coordinate axis system. So how I would start with, I would draw the line x is equal to a quarter. If I'm going to make this 1, just so we have a bit more space, then x equals to a quarter would be here. If you can't remember how to show your x equals to or a y equals to line, remember the x equals to lines go through the x-axis. So that's the easiest way to remember. So it's an x equals to a quarter. So it has to go through or cut through the x-axis. Now, x is bigger than 1 over 4. Remember, less than is to the left, so bigger than has to be to the right. So I'm going to shade all of the area here to the right of the line. As it's a bigger than and not a bigger than or equal to, I'm just going to have it as a dotted line. Okay, so that's the answer here. X is bigger than 1 over 4. And I've drawn a little diagram here that's going to help us with the part C later on. Stay tuned for the part B. Hi. Now we're going to do the June 2005 question from C1. If you're doing the new International A-Level, that would be like a C1-2 for you. Okay, so as we can see, we've got a quadratic inequality. That's an inequality with an x power 2. The first step for these is always to factorize. So what we're going to do, I'm going to make my little table appear here, is we need to look at these numbers and we do the first one times the last one. So we want two numbers that multiply for 2 times 3, 6, and add up for minus 7. I've written out here all of the factors of 6. So you could have 6 times 1, minus 6 times minus 1. Remember, if it's a plus 6, you need to check it could be positive times positive, but it could also be negative times negative, which it will be because they have to add together for minus 7. It could also be 2 times 3 or minus 2 times minus 3. So don't forget to check both plus plus and minus minus. If you plus those same two numbers together, so for example here, 6 plus 1 is 7. We're looking for minus 7. So it's going to be minus 6 minus 1 will be minus 7. And minus 6 times minus 1 will be 6. So this is the correct line that we need to look for. Minus 6 and minus 1. I'm going to rub this out now. If we go back now to our original equation, I'm going to split this up into minus 1x and minus 6x. You can see minus 1x minus 6x will still give you minus 7x altogether. I'm just splitting that into two parts now. I'm going to rewrite here the 2x squared from here and also the plus 3. Now, what to do next? You take the first two, so in our case the 2x squared and the minus 1x, and you take the highest common factor. That is, what can we take out of both of them? So we can't take anything out of 2 and 1, but we can take x from x squared and x. So if I take the x outside the bracket, then this here needs to be 2x, because x times x will give me my x squared. Here I've got my minus, and I need this to be 1, because x times minus 1 will give me minus 1x. So you factorize the first two here. We're going to do the same process here on the second two. What can we take out of minus 6x and plus 3? Well, we can take out minus 3. So if I take out minus 3 here, inside the bracket would be 2x minus 1. Because minus 3 times plus 2 will give me the minus 6, and there's my x. And minus 3 times minus 1, that double minus, will give me plus 3 times 1, 3. As you remember, these two brackets need to always be the same. My two final answers, it's going to be x minus 3. And my repeated bracket, 2x minus 1. From here, we're going to solve to get the two places where this graph here will intersect the x-axis. So we're going to make each of these brackets in turn equal to 0. So let's start with the first one. X minus 3 is equal to 0. So I'm going to move the minus 3 across the equal sign. And remember, it will change to plus 3. So that will be x equals 3. That will be my first solution of the quadratic equation. And my second solution will come from the second bracket. And I'm going to do the same again. I'm going to do 2x minus 1 equals to 0. So 2x equals 2. The minus 1 will go across the equal sign. And that will change to plus 1. Now I'm going to divide both sides by what's in front of the x, which is the 2. X is equal to a half. So I've got two solutions now. I've got x equals to 3, x equals to a half. If you're struggling to get to this stage, then you need to revise how to factorize non-monic quadratics. That's really important, not just for this section of inequalities, but for the whole course. You need to be really, really good at that. Once we've got these two solutions, we're going to do a quick graph. So now I'm going to draw the coordinate axis system. I'm going to draw an x-axis and a y-axis. Okay, I'm going to make two boxes 1. So if I put in, that would be 1, 2, 3. I'm going to put in my two solutions. So my 3 will go here. That will be x equals to 3. And my purple solution, x equals to half, will be here. In order to know if it's a happy face or a sad face shape, you need to go back and look at what's in front of the x squared. So in front of the x squared, we had a positive 2. So our shape is going to be the happy shape, the smiley face. So here we go. We're going to just draw a rough smiley face. we need to now know, do we shade above the x-axis or below the x-axis? Now, if you remember, that all depends on this sign here. If we have bigger than 0, we need to shade above the x-axis. So I need to shade here and here. So I'm going to take a different color, and I'm going to shade the two places where my graph goes above the x-axis. Now remember, if you shade two different places, that means you're going to have two different answers. Let's start with the purple answer. We're going to have here x is less than or to the left of a half. So we're going to have x is less than a half. Everything to the left, less than to the left. The two L's are always together. So that's my first solution. Now my second solution is going to refer to this the pink answer that we found, which is going to be bigger than or to the right of 3. So my pink answer will be x is bigger than 3. So quick summary. What did we do? We started by factorizing our non-monic quadratic. So that was a little bit tricky, but we ended up with two brackets. We let each bracket equal to 0 and solve for x. So we had two answers for x. We then drew a coordinate axis system and put in our two answers for x. Because our quadratic was bigger than 0, we shaded above the x-axis, above. It was a smiley face because the number in front of the x squared was a positive number, not a negative number, a positive number. So positive, think positive smiley face. We shaded two different areas, so we have two different answers. I hope that helps. Please stick around and watch the part C. Hi, this is the part C, or the final part on June 2005 from the C1 paper. Now, this is what makes this question a little bit tricky. You're asked to shade the region or find the answer where both 3 with bracket 2x plus 1 close bracket is bigger than 5 minus 2x, and 2x squared minus 7x plus 3 bigger than 0 are true. So if you look closely, you'll remember that this was the same equation that was in part A, and we've already done that. So let's look at our diagram from part A. We shaded everything to the right of x is equal to a quarter. Now this one, similarly, is our part B. So we'll put this one down here, and we'll put in our answer from the part B. So what we're going to do is we're going to draw both graphs on the same graph. So let's use this one. This one's a bit more complicated. All we have to do is draw on top this one where we had the x equals to a quarter line, and we shaded everything to the right of it. So I'm going to take this diagram, I'm going to put in red the line x is equal to a quarter. So that's a half. Remember, we had two boxes for 1. So it would be roughly here. And we shaded everything. And we shaded everything to the right of this one. So if we were going to use this, we could shade in, for example, green. Now, if it's both, it would have to have both colors. It would have to have green and yellow. And that's only going to occur in this tiny little space here, which is starting at x equals to a quarter and stopping here. It will also occur over here again. You see here you've got the yellow line that's shaded, but also the green. So there's two answers here, and that's going to be a quarter x and a half. That's going to be the first solution. But it will also be x bigger than 3, because 3 and afterwards you're going to always have the yellow shaded, but you'll also have the green. So that's a little bit complicated, but you just take your two graphs, you draw them on the same diagram or the same graph, and then you look where do you have both graphs shaded, or both colors if you're going to use colors. I hope you find that useful. Bye for now.